Welcome aboard the interstellar Starship Genesis. Together, we'll journey beyond the boundaries of known space, explore distant worlds, and witness the quiet wonders of the universe. If you enjoy relaxing sci-fi sleep stories like this, please consider liking this video and subscribing to join us on future voyages. Now find a comfortable place to rest. Take a slow, gentle breath, and whenever you're ready, let the journey begin. Chapter 1. Lost. The first thing navigation told us was that they could no longer tell us exactly where we were. That was not supposed to happen. Genesis had been traveling between the stars for decades, and navigation had always given us a position. Not an estimate, a position. We knew where the ship was, how fast it was moving, and where it would be after the next course correction. That morning, the answer was different. Navigation gave us a region of space. It was enormous. Genesis could be somewhere inside it. We just didn't know where. The bridge was quiet when I arrived. The navigation display showed the ship's calculated position, surrounded by a widening field of uncertainty. I had seen position margins before. They were normally so small that they were meaningless to anyone outside navigation. This one was different. It stretched across a distance measured in astronomical units, and it was growing. Navigation had been recalculating the solution for hours. The ship itself was functioning normally. Its engines were stable. Its sensors were working. Nothing had failed. That was what made the situation so unsettling. Genesis had not lost navigation. Navigation had lost certainty. The problem had begun with the stars. Astrometry had compared several reference stars against the positions in our astronomical catalogs. The measurements didn't agree. At first, the differences were small enough to dismiss. Then another reference star disagreed. Then another. The observations were repeated. The results remained the same. Navigation checked Genesis's velocity. The engines confirmed it. The ship's inertial systems confirmed it. The calculations were checked again. They were correct. And yet the stars were not appearing where the navigation models said they should. The obvious explanation was that our position was wrong. That was the first thing everyone wanted to believe. If Genesis had simply drifted from its expected trajectory, we could calculate the correction and continue. But there was a problem. We didn't know which direction the error was in. A small mistake in our position, accumulated over an enormous distance, could place Genesis millions of kilometers from where we believed it to be. And the farther we traveled, the worse the uncertainty could become. That meant navigation couldn't simply tell engineering to turn the ship around. To turn around, we needed to know which direction home was, and the last reliable position we had was already far behind us. For the first time since leaving Earth, the phrase "go home" had become more complicated than it sounded. We could point Genesis toward the region where Earth should be. But should be was no longer good enough. We were now traveling through a part of the galaxy that humanity had never charted directly. We had known that when we entered it. What we hadn't understood was what that would eventually mean. The maps behind us had been built from observations. The space ahead had not. And now Genesis was discovering the difference. We were not drifting helplessly through space. The ship was still under control. The engines still worked. Life support was stable. Our course could still be changed, but we no longer knew our position precisely enough to trust every decision about where to go next. And that left us with the most dangerous problem an interstellar spacecraft could have. We knew how to travel. We knew how to survive. We just didn't know where we were. And somewhere ahead of us, beyond the edge of every reliable chart humanity had ever made, was the rest of the galaxy. Chapter 2. The Position. Navigation did not begin by searching for somewhere to go. They began by trying to prove that we were where we thought we were. For the next several hours, the bridge became unusually quiet. Navigation started again from the beginning, this time without relying on the original position solution. They began with Genesis itself. The ship's velocity was known. Its inertial systems had been measuring its motion continuously throughout the voyage. Engineering confirmed the propulsion data. Nothing suggested that Genesis had suddenly accelerated or drifted from its expected course. The ship was moving exactly as the engines said it should, so navigation looked outward. They turned to the stars. The light reaching Genesis carried information about where those stars had been when that light began its journey toward us. That had always been part of interstellar navigation. The farther away a star was, the farther back in time we were seeing it. Humanity had accounted for that. Our astronomical catalogs contained measurements of stellar positions and motion gathered over generations. But those measurements were never perfect, and Genesis had been moving for decades. We were no longer looking at the galaxy from the same place where those measurements had been made. Navigation began comparing several independent reference stars. Each one produced a slightly different estimate of Genesis's position. The differences were small, but they should have converged. They didn't. Astrometry examined the stars again, their apparent positions, their measured motion, the uncertainty in the observations. Nothing immediately explained the pattern. Then someone suggested the simplest possibility. The stellar data might be out of date. It was a reasonable explanation. The galaxy was not static. Stars moved through space. Their positions changed. And even a tiny error in a star's predicted motion could become significant after decades of travel. So astrometry began rebuilding the reference model using the observations Genesis had collected during the voyage. The new calculations corrected some of the discrepancy. For a moment, it looked as though we had found the problem. Our old data had simply become less accurate as Genesis traveled farther from Earth. But the correction did not solve everything. There was still a difference, a larger one. Navigation checked the revised model again. Astrometry checked it independently. The result remained the same. The old astronomical data had been part of the problem, but it was not the whole problem. That was when the mood on the bridge changed, because an outdated catalog was something we could fix. A deeper disagreement between our measurements and the sky was something else. Navigation expanded the calculation. Instead of giving us a single position, the system began showing a range of possible positions. Genesis was somewhere inside that region. The region was enormous, and it was growing. Engineering was asked to calculate what a major course correction would require. The answer was not catastrophic, but it was significant. We had enough propulsion capability to make a correction. We did not have enough to make careless ones. Every unnecessary adjustment would cost us something: fuel, energy, time. And after decades of travel, Time was no longer an abstract number. It was part of the mission itself. Then, astrometry found something that stopped the discussion completely. One of the reference stars we had relied upon for years was moving differently from the model. Not enough to explain the entire discrepancy, but enough to prove that something in our understanding of our position was still missing. Navigation ran the solution one more time. The uncertainty remained. We still had a position. We simply couldn't say that it was the position with the confidence we had always expected. And that left us with a problem that no one on the bridge wanted to say aloud. Genesis could still travel. We could still change course. We could still calculate where we were most likely to be. But we could no longer treat that calculation as certainty. For the first time in decades, we were navigating through space where every answer came with a margin of doubt. And the farther we traveled, the larger that doubt could become. Chapter 3. No Way Home. The navigation team spent the next several hours trying to answer a simpler question. If Genesis was not exactly where we thought it was, could we still find our way back? At first, the answer seemed obvious. Earth was behind us. The route we had traveled was recorded. Every major course correction had been logged. Genesis knew the direction in which we had come, but knowing the direction of travel was not the same as knowing where we were now. That distinction became important very quickly. Navigation reconstructed our journey from the beginning. The calculations were remarkably consistent. We had followed the planned trajectory. There was no single moment when Genesis had suddenly wandered away from its course. The uncertainty had accumulated gradually, a fraction here, another fraction there, small enough that none of it had mattered at the time. After decades of travel, those small differences had become something much larger. Navigation projected the uncertainty backward toward the region of space we had left behind. The result was uncomfortable. There was no single point waiting for us. There was a corridor, a widening region through which our previous path could have passed. Earth was somewhere far beyond it. We knew that. But our ability to point directly toward Earth depended on knowing exactly where Genesis was now, and we didn't. Engineering calculated what would happen if we simply reversed our velocity and began traveling back along our previous course. The answer was not reassuring. We could reverse course, but if our current position was wrong, the error would follow us. We might spend years traveling toward the wrong section of space, and every correction made along the way would consume propulsion resources that could not be recovered. For the first time, turning around did not feel like going home. It felt like making another guess. Navigation tried another approach. Instead of asking where Earth was, they searched for reference points we could still identify with confidence. Known stars. Objects whose positions had been measured independently. Sources of light that could give us another way to determine our position. One by one, they were compared against the observations from Genesis. The results narrowed the possibilities, but not enough. The region of uncertainty remained enormous. Then astrometry noticed something. The stars producing the greatest disagreement were not scattered randomly across the sky. They were concentrated in one direction. That shouldn't have happened if the problem were simply accumulated measurement error. There was a pattern. Navigation began isolating the stars within that region. The more they examined them, the clearer the pattern became. Genesis's position was not equally uncertain in every direction. The uncertainty was growing more strongly toward one part of the sky. That changed the problem. If the discrepancy had been random, we would have been dealing with accumulated error. But if it had a direction, then we needed to understand why. Astrometry ran the calculations again. The result did not give us an answer. It gave us another possibility. The uncertainty in our position was being amplified by the motion of the stars we were using as references. The models had accounted for stellar motion, but they had been built from observations made from a very different place in the galaxy. Genesis had spent decades moving away from that original reference point. The farther we traveled, the more sensitive our position became to small uncertainties in those measurements. It was not enough to explain everything, but it explained why the problem was becoming worse. And it gave us a new way forward. We needed a reference that did not depend entirely on the same stellar measurements we were already questioning. Something distant, something stable, something whose position could be determined independently. Astrometry began searching through the observations Genesis had collected during the voyage. There was one possibility: a distant astronomical object whose motion could be measured with much greater confidence than the stars surrounding us. If they could identify it precisely, it might give navigation the fixed reference we needed. For the first time since the problem began, there was a possible way to establish exactly where Genesis was. But there was a problem. The object was far ahead of us, and we had never planned to travel toward it, which meant that finding our position might require us to make a decision. We could continue toward our original destination, using an increasingly uncertain navigation solution. Or we could change course toward the one object that might finally tell us where we were. And if we chose incorrectly, we could spend years making the problem worse. Chapter 4. The Beacon. The object astrometry had found was not a star. It was a pulsar, a rapidly rotating neutron star sending out precisely timed pulses of radiation through the galaxy. Genesis had detected it before, but we had never used it for navigation. It had always been too distant to matter. Now it might be exactly what we needed. The first calculation suggested that we could use the pulsar as an independent reference. Its pulses arrived at extraordinarily regular intervals. They were not perfectly regular. Nothing in nature was. But the variations were predictable enough that navigation could compare the timing of the pulses received by Genesis against the timing expected from a known position. If the timing was different, our position was different. It was a simple idea, and for the first time since the problem began, we had a reference that did not depend entirely on the same stellar measurements that had created our uncertainty. There was only one problem. The pulsar was far ahead of us. The original solution suggested that Genesis would need to alter course to use it effectively. Engineering began calculating what that would cost. It was not a small correction. We could make it, but doing so would consume propulsion resources and add time to the journey. The bridge waited for navigation to decide whether the correction was justified. Then astrometry found something unexpected. We didn't need to go there. The pulsar signal was already reaching Genesis. We could measure its pulses from where we were. The course correction was canceled. Instead, the ship went quiet. Navigation began recording the arrival times. 1 pulse, then another, then another. Each arrived at an interval that could be compared against the pulsar's known timing. The calculation took time. The difference we were looking for was incredibly small. But Genesis had been built to measure small things. The ship's clocks were synchronized. The signal was checked. The calculation was repeated. Then navigation ran it against the observations from several different points in the sky. For the first time, the uncertainty around Genesis began to shrink. Not quickly, but visibly. The enormous region surrounding our possible position began narrowing. The bridge watched in silence as a solution changed. The stars had given us possibilities. The pulsar gave us a reference. Eventually, navigation produced a new position. This time, it came with a confidence level we could work with. Genesis was not where our original navigation solution had placed us. We had been drifting away from the planned trajectory for much longer than anyone had realized. The difference was substantial, but we were not lost. Not anymore. We knew where we were, and for a few minutes, that felt like the end of the problem. Then navigation compared our new position with our original flight plan. The room became quiet again. Our current position was not simply offset from the planned route. The error had placed Genesis on a completely different trajectory through this region of the galaxy. We could still correct it. Engineering confirmed that. But the correction would require a significant burn. And before anyone approved it, Astrometry made another observation. The new position placed something unexpected on our projected path. Something that had not been part of the original mission. Something we would never have known about if Genesis had remained on its original trajectory. For the first time, being lost had given us a location, but that location had given us another problem. What had Genesis been traveling toward without knowing it? Chapter 5. The Unexpected Light. The first thing we did was verify the calculation. Nobody wanted to make a decision based on a single navigation solution. The pulsar had given us a much better position, but engineering still needed to know exactly what that position meant for the ship. Navigation projected Genesis forward from the new coordinates. The original route remained on the display. So did our revised trajectory. The two paths separated slowly. At first, the difference looked insignificant. Then the distance between them began to grow. We'd been traveling through the galaxy for decades. A small error made early in the journey could become enormous after enough time. Genesis had not suddenly turned away from its destination. We had simply been traveling along a path that was slightly different from the one we believed we were following. Now that we knew where we actually were, we could finally see where that path was taking us. Navigation extended the projection. Something appeared on the display, a small dark object far ahead. It was not part of our original flight plan. Astrometry searched the astronomical catalogs. Nothing matched it. They searched the observations Genesis had collected during the voyage. Still nothing. That did not mean the object was impossible. We were looking into a region of space that humanity had never surveyed closely. There could be countless objects we had never detected. The first assumption was simply that we had found one. Astrometry began examining the light around it. The object itself was extremely faint, but the stars behind it appeared slightly distorted. The distortion was subtle, yet it was measurable. Something with significant mass was passing between Genesis and those distant stars. That gave us our first useful clue. The object was not simply dark, it was massive enough to affect the space around it. Astrometry began calculating its mass from the gravitational distortion. The first estimate was large, much larger than an ordinary planet. A brown dwarf became the most likely explanation, a body too small to sustain the fusion of a normal star, drifting through the galaxy without a conventional planetary system around it. It made sense for a while. Then the next measurement arrived. The estimated mass was higher than the first calculation suggested. Astrometry repeated the observation. The result remained. The object was exerting more gravitational influence than we could comfortably explain with the original model. Nobody immediately knew what that meant. It could still be a brown dwarf. The observations were not yet sufficient to rule that out. So we kept watching. Hours passed. The object remained almost invisible. The navigation noticed something unexpected. Genesis was not simply passing near it. Our revised trajectory was carrying us toward it, not directly into it. The distance was still enormous, but close enough that we would eventually have to decide whether to alter course. Engineering calculated what a diversion would cost. The correction was possible, but it would consume propulsion and add time to a journey that had already lasted decades. Continuing toward our original destination would be simpler, safer, more efficient. But this object was unlike anything we had encountered during the voyage, and we had only found it because we had become lost. Astrometry continued observing. Then, another measurement appeared. The gravitational distortion around the object was not behaving exactly as expected. There was another influence nearby. Something much smaller was affecting the observations. At first, we assumed it was simply another distant body passing through the field of view. Astrometry checked the surrounding stars. The signal remained. It was not a background star. It was moving, and it appeared to be moving in relation to the dark object. The bridge went quiet. We'd spent decades traveling through space without knowing this system was here. Now we were beginning to see that the dark object was not alone. There was something orbiting it. We didn't know what it was. We didn't know how large it was. And we didn't know why we had never detected the system before. But for the first time since Genesis had entered this uncharted region, being lost had given us something we hadn't expected, a destination, and perhaps a reason to stop searching for the path we had lost. Chapter 6. The Dark Companion. We did not change course immediately. Finding something in the darkness was not the same as having a reason to approach it. Engineering wanted to know what the diversion would cost. Navigation wanted to know whether the object actually lay close enough to justify the risk. And astrometry wanted more observations. So Genesis continued along its revised trajectory, while the instruments watched the distant system. The smaller object became easier to track. It was moving, slowly at first. Then, as more measurements accumulated, its path became clear. It was not passing through the region by chance. It was orbiting the larger object. That changed our understanding of what we were looking at. This was not simply a dark body drifting through interstellar space. It was a system. A small world moving around something much larger. Astrometry calculated the orbit. The result was surprisingly clean. The smaller object followed a stable path around the unseen mass. That allowed the crew to estimate something we could not observe directly: the mass of the object at the center. The calculation was repeated several times. The answer barely changed. It was far too massive to be an ordinary planet, and yet we could see almost nothing from it. There was no visible surface, no obvious atmosphere, no normal stellar light. Only the gravitational influence it exerted on everything around it. The first explanation was a brown dwarf, a failed star, something massive enough to dominate the smaller body's orbit, but too cool and faint to resemble the stars we were accustomed to seeing. It was plausible. In fact, it was the explanation most of us expected. But astrometry wasn't satisfied. The gravitational measurements were becoming more precise. The mass was higher than expected, much higher. The object was compact, extremely compact. That mattered. A brown dwarf could contain enormous mass, but it would still occupy a substantial volume. Its gravity would behave differently at close range. The measurements we were receiving suggested something far more concentrated. The crew ran the calculations again, then again. Each time, the same possibility became harder to ignore. The object might not have a surface at all. There was a long silence on the bridge. Nobody wanted to say the word first. Eventually, astrometry did. A black hole. Not the enormous kind found at the center of a galaxy. A stellar mass black hole. The remnant of a star that had once been much larger than our sun. If that was what we were seeing, it explained why the object had remained invisible. There was no surface reflecting light, no ordinary stellar atmosphere, nothing for our telescopes to see directly. We had found it because we had noticed what its gravity was doing to everything around it. But there was still a problem. A black hole traveling through interstellar space was rare enough. A black hole with a companion world was something else entirely. The smaller object continued its orbit. Its path was stable. Its distance from the black hole was enormous. And yet the two had remained gravitationally bound while traveling through the galaxy. We began searching the system for any additional evidence. There was no bright star, no obvious cloud of gas, no large field of debris, nothing that would have announced the system from a distance. It had simply been there, hidden in the darkness, and then we understood why Genesis had never seen it before. It wasn't that humanity had failed to look carefully enough. There was almost nothing to see. We had spent generations building maps from the light that reached Earth. But some objects in the galaxy did not announce themselves with light. They announced themselves with gravity. Genesis had spent decades learning how to navigate by the stars. Now far beyond the regions humanity had explored, we had encountered something that could not be found by looking for a star. We had found it because space around it was behaving differently, and the discovery created a new question. The black hole itself was interesting. The companion world was even more interesting, but there was one thing about its orbit that astrometry could not explain. The planet was not where our models predicted it should be. It was being pulled slightly away from the orbit we expected. Something else was influencing it. Something that was not visible. Something else was moving through the darkness with them. Chapter 7. The disturbance. The orbit of the smaller world should have been simple. The black hole was massive enough to control its motion across enormous distances. The companion followed a stable path around it, but the orbit was not behaving exactly as our calculations predicted. The difference was small, too small to notice from a single observation, so we watched. Genesis remained on its revised trajectory while astrometry continued recording the system. Days passed, then weeks. The longer we observed the companion, the clearer the pattern became. Something was disturbing its orbit. The first explanation was simple. There could be another star nearby. A star passing through the system could exert enough gravitational influence to disturb the companion without being part of the system itself. That happened throughout the galaxy. Stars moved. Systems passed one another. Gravity reached across enormous distances. So we searched the surrounding sky. Nothing appeared. Astrometry expanded the search. Still nothing. There was no visible object large enough to account for the disturbance. That left another possibility. Perhaps the effect was not real. The black hole's gravity was extreme. Our models were good, but they had been built from observations of objects that were far easier to study. Perhaps the strange motion was simply the result of measuring a world orbiting in an environment we had never observed this closely. That explanation was easier to accept, and for a while, it seemed convincing. Then another observation arrived. The companion had moved again. The same disturbance was there. It had not disappeared. Astrometry repeated the calculation using a different set of measurements. The result was the same. The effect was real. Something was influencing the orbit. We still could not see it. The crew began calculating what kind of object could produce the observed change. A small object nearby could have the effect we were measuring. A larger object farther away could produce something similar. There was no single answer, but the possible locations could be narrowed. Astrometry began projecting those possibilities forward. That was when the investigation became more uncomfortable. The disturbance was not stationary. Whatever was causing it was moving, and it was moving through the same region of space as Genesis. We ran the calculation again. The object was still too far away to pose any immediate danger, but its projected path was beginning to overlap with ours. Not the path we had originally planned. The path Genesis was actually traveling, the same trajectory that had taken us away from our intended route. The realization was difficult to ignore. We had become lost. That had brought us to the black hole. The black hole had led us to its companion world. And the companion's orbit was now telling us that something else was moving through the darkness nearby. We didn't know what it was. We didn't know how large it was, and we couldn't see it, but we could measure what it was doing. Engineering began calculating possible course corrections. We could move farther away from the projected path, but doing so would cost propulsion, and we still had not decided whether Genesis would continue toward the original destination or remain in this system long enough to understand what we had found. Then astrometry finished another projection. The unseen object was not simply passing through the system. Its trajectory would bring it much closer to Genesis than the earlier calculations had suggested. Not soon, not dangerously soon, but close enough that we could no longer treat it as an interesting observation in the distance. For the first time, the unknown object had become part of our own journey, and we still had no idea what was moving through the darkness. Chapter 8. The Decision. For the first time since we discovered the system, engineering asked a question that had nothing to do with what we had found. It asked what would happen if we stayed. The invisible object had passed through the outer regions of the system. Its gravitational influence had disturbed the smaller world, but the system itself was stable. There was no collision, no sudden collapse, nothing that required Genesis to escape. The danger had passed before it ever became a danger, but the encounter had left us with a much more difficult problem. We now knew where Genesis was. The pulsar had given navigation a reliable reference. Our position was no longer a region of uncertainty. We knew where we were. We also knew that we were not where the original mission plan had expected us to be. That difference mattered. The original trajectory had been calculated decades earlier. Since then, Genesis had traveled farther and farther into a region of the galaxy that humanity had never directly surveyed. The small errors in our navigation had accumulated. They had carried us away from the path we thought we were following. Now we had a choice. We could correct our course. Engineering calculated the required burn. It was possible. Genesis had enough propulsion capability to return toward the original route, but it would not be free. The correction would consume fuel. It would add time to the journey. And once we committed to it, there would be little reason to make another major change later. The other option was simpler. We could stay on our current trajectory, not because we had planned it, not because it was the most efficient route, but because it was the route Genesis was actually traveling. That idea felt strange. For decades, we had thought of the mission as a line connecting 2 points. Earth behind us, the destination ahead. Everything between them was the journey. Now that line had broken. There was no longer a single route. There was only our current position and the choices that followed from it. Navigation projected both possibilities. The original route curved back toward the destination we had selected decades earlier. Our current trajectory continued into the uncharted region. The difference between them was not simply distance, it was opportunity. The original route was familiar. We knew why we had chosen it. We knew what we expected to find along it. The other path was unknown. We had no guarantees. We didn't even know what was ahead. But we had already learned something from being lost. The galaxy contained things our maps had never shown us. A black hole, a hidden companion world, a passing stellar remnant. None of them had been part of our mission. None of them had been waiting at a marked location on a chart. We had found them because Genesis had traveled somewhere humanity had never traveled before. The decision was not made immediately. There was no dramatic announcement, no single moment when everyone agreed. Instead, the crew began reviewing what mattered. Fuel, time, the condition of Genesis, the distance still separating us from the original destination, and the uncertainty of what lay ahead. Eventually, navigation gave us the numbers. Returning to the original route was possible. Continuing forward was also possible. Neither choice was immediately dangerous. That made the decision harder. If one path had meant survival, and the other meant certain failure, there would have been nothing to debate. But both paths led somewhere. One led back toward the mission we had planned. The other led farther into the galaxy. I remember looking at the display for a long time. The old route was still there, a line we had trusted for decades. Beside it was the path Genesis was actually traveling. a line that had never existed on any human chart. We had spent our entire journey trying to reach the stars. Now the stars were beginning to show us how little of them we understood. And perhaps that was the real consequence of becoming lost. It wasn't simply that we had lost our way. It was that we had discovered there was more than one way to go. Navigation waited for the decision. And somewhere beyond the limits of our instruments, the galaxy continued without caring which path we chose. Chapter 9. Beyond the map. The decision came quietly. Genesis would continue forward. We would not attempt to return to the original trajectory. There was no single reason for the decision. The original mission was still important. The destination we had planned to reach still mattered. But returning to the old route would mean spending fuel and time correcting a journey that had already carried us somewhere new. And more importantly, we now knew that the route we had planned was based on what humanity had known when Genesis left Earth. That knowledge had changed. We had changed with it. The navigation team rebuilt the flight plan from our actual position. This time, there was no assumption that Genesis needed to return to the line we had once drawn through the galaxy. We started from where we really were. The pulsar gave us our reference. The stars around us gave us additional measurements. Our trajectory was recalculated from the beginning. For the first time in weeks, the navigation display showed a single path forward that we could trust. It wasn't the original path. It was ours. The engines adjusted Genesis gradually. The change was almost impossible to feel. There was no dramatic turn, no sudden movement, just a slow alteration in our course that would become significant over the years ahead. The old trajectory remained visible on the display for a while. Then the distance between the two paths began to grow. Eventually, the original route disappeared beyond the edge of the navigation screen. Genesis was no longer trying to find its way back to where we thought we belonged. We were moving forward again. And yet the experience had changed something in all of us. Before this journey, we had thought of navigation as certainty, a position, a destination, a route connecting the two. Now we understood that navigation was something more fragile. Our position depended on measurements. Our measurements depended on models. And those models depended on how much of the universe humanity had been able to observe. The farther Genesis traveled, the more those assumptions would be tested. That did not make the stars unreliable. It made them honest. They had never promised to give us a perfect map. We had simply mistaken our maps for the galaxy itself. Later, I returned to the observation section. The black hole was already becoming difficult to distinguish from the surrounding darkness. Its companion world had disappeared into the distance. The system we had stumbled upon would eventually become another entry in humanity's growing knowledge of the galaxy, if we survived long enough to send the information home. I looked ahead. There were no familiar stars, no destination visible to the naked eye, no line painted across the darkness showing where Genesis should go next. Only the stars themselves. And for the first time, that didn't feel like being lost. It felt like being free of the map. Genesis continued forward. Decades had carried us this far. Decades more might carry us somewhere humanity had never imagined. Somewhere ahead, there would be another star, another world, another question. We didn't know what it would be. That was the point. For most of human history, exploration had meant traveling towards something that existed on a map. Genesis had reached a place where the map ended, and beyond it, the galaxy was still there, waiting to be discovered. Not because it had been hidden, not because it had been calling us, simply because we had never been far enough away to see it before. Genesis continued into the darkness, and this time, we knew exactly where we were going. Forward, our journey comes to an end. For now. Thank you for traveling aboard the Interstellar Starship Genesis. If you'd like to continue exploring the stars with us, please consider subscribing for future voyages. Until we meet again, sleep well and safe travels.